Okay, 4.3-4.4 quiz review. Your quiz is going to be this week on these two lessons. Here's a lot of terminology to remember and know. The terms on the left here are from lesson 4.3. The terms on the right here are from lesson 4.4. Okay, you should know each of these terms and what they all mean. On the next slide. The next slide is a summary of lesson 4.4. Circuit versus path. Now remember, we did two different types of graphs. We did regular graphs, right? And then we did the graphs that had the arrows. Those were the special kinds of graphs. Those were called digraphs. So we learned two sets of rules for each. We learned rules for when it's a circuit for a regular graph, as well as when it's a path for a regular graph. And then we learned two more rules for circuits versus paths for directed graphs. Okay, so let's do an example of each right now. We'll do a regular graph and a directed arrow graph to review the rules for circuits and paths. Okay, but this slide is very good. It just gives you a summary of when to tell which is which. Let's look at this one right here. This first one. This is a digraph. See the arrows? So we're going to try to determine if this is a circuit or a path. Okay, so you have to count the arrows in and out at each point. At each point, count the ins and outs. So A has one arrow in and one arrow out. D has one in and one out. Right? E has one in and one out. Just count the arrow heading into the point and out of the point. You want them all to match everywhere. If they're all the same, if the ins and outs are the same everywhere, then it's going to be a circuit. But that looks like it's going to fail right here. F has two in, but only one out. So we know it's not a circuit. G has one in and one out. C has two in and two out. B has two out and one in. So we know it's not a circuit. But if we look at this and this right here, the 2 points at which the ins and outs differ. So what point is this? B, we have one in and two out. And then at point F, we have two in and one out. That's going to make this a path. When you have 1 point with an extra out and another point with an extra in, it's going to be a path. And more specifically, you must start. When you're starting to draw through your map, you must start at the extra out. So point B is going to be your start, and then you will end at the extra in. Point F will be your end. So now we can answer these questions, A, B, C. Does the following have a directed Euler circuit? No, this is not a circuit. We already determined that it is a path. Yes, it's a path. If it's a path, which vertices can be the starting vertex? The start must be B. And the end must be F. There's no other way around it. Those have to be your starting and ending points, or else you won't be able to navigate your way through the map. Okay? You could skip part C. So that's a path with arrows. It's called a digraph. Now let's do one that doesn't have arrows. This one you could do. This was lesson 4.3 right here. Just this one problem is a review of that whole lesson. Okay, look at these right here, A and B. We'll do these last two. These are just regular graphs. These are not directed arrow graphs here. So with these, you have to count what's called the degree at each point. So you count the number of lines touching each point. 1, 2, 3, 4. The degree there is 4. 1, 2, 3 here, 2 here, 3 here, 2 here. And the rule is, if they're all even, it's a circuit. If exactly 2 of them are odd, it's a path. So that's what we have here. We have exactly 2 odds, which makes this a path. Which means that you'll be able to get through this map, but you'll have to start and end at different locations. Okay? And more specifically, you will have to start and end at the two odds. So ready? I'm going to start here. And my prediction is we're going to end at the other odd. So we can navigate our way through this map without crossing over the same line twice and start and end at the two odds. And we did that. We accomplished it. Okay? And then finally this one here. Here we have a 2, here we have 4, here we have 2, here we have 4. Again, I'm just counting the lines that are connected to each dot. This one has 4, this one has 2, this one has 4. They're all even. It's going to be a circuit. All evens means circuit. Circuit means you could pick any point you want and you will start and end at that same point. So I'm just going to pick a random point there. We're going to start and end there. Watch. Start and end. I'm going to be able to go through this whole diagram and get back to this point. Ready? Without crossing over the same line twice. You could go through the same dot twice, but you can't cross over the same line twice. And look at that. We get all the way back to our starting point without retracing any of the lines. That makes this a circuit.